This is an example of how we can use the variation of parameters method to solve a second order linear ordinary differential equation. So let's look at this differential equations. Second order linear ordinary, and we want to use the variation of parameter methods. Okay. Keep in mind that we can use this method by finding first solution to homogeneous equations. Second, finding V1 and V2, which is a part of special or specific solution to the order or to the differential equation, big Y of t. So we call this is V1 and we call this is V2, and you take V1 multiplied by Y1 plus V2 multiplied by Y2 to get big Y of t. Okay. All right, so first identify the homogeneous equations. It's going to be y double prime plus 4y equals to 0. And we find the characteristic polynomial r squared plus 4 equals to 0. So then r equals to plus and minus 2y. Okay. From here, we know that the solutions y0t is c1 cosine of 2t plus c2 sine of 2t. And I call this is y1 and this is y2. If this is y1, then my y1 prime equals to -2 sine of 2t, and my y2 prime equals to 2 cosine of 2t. The reason why I want to find y1 prime and y2 prime is because I need to find the Kronskian of y1 and y2. And I remember that is equal to y1 times y2 prime minus y2 times y1 prime. So it's going to be equals to y1, y2 primes, which is 2 cosine square of 2t, minus y1 prime times y2, which is -2, which is positive, sine of 2t. Okay. And then I'm using one of the trig identities to simplify this. It's going to be just 2. Because you know that sine square of t plus cosine square of t equals to 1. It's the first trig identity that we're going to use. Okay, so it's 2. The Kronskian of y1 and y2 is 2. Now, the next part is we just need to figure out what is V1, what is V2, and then we put V1 and V2 in this formula to find the general solutions. Let's go to find V1. So V1, by the definitions, is going to be equals to T0 to T negative Y2. I just rewrite in terms of S, F of S, W, V1, V2. ds. Okay. Well, what is f of s? Look at these functions here. This is f of t. Then f of s is just the same as this function, but you replace t by s. Okay. y2, we already identify y2 as sine of 2t. And we know the Kronskian of y1, y2 is 2. T0 is here, which is just 0. 0, t, negative sine of 2t times f of s, which is 8, times tangents of s. Again, we don't have t. We should replace t by s. Divided by 2 ds. Okay. Now you have this and this will be gone. 4, I move the 4 in front. 0t, sine of 2s and tangent of s. Try to remember where I have any trig identity. So sine of 2s equals to 2 sine of s times cosine of s. So then I can just replace sine of 2s like this. So it's going to be negative, so I put the negative out here. 2 sine s cosine of s. Tangent is sine of s divided by cosine of s ds. Okay. Then we should cross this out, and combine all of this to get -8, 0 to t, sine square of s ds. Okay. The sine square, we have to find this integral. And luckily, we have another trig identity that involves sine square. So sine square of s equals to 1/2 of 1 minus cosine of 2s. So using this trig identity, I will try to find v1, -8, 0t, 1/2, 1 minus cosine of 2s ds. Okay, so simplify this, we'll have 4, -4. Integral of 1 is going to be just s. The integral of cosine 2s is going to be negative cosine, negative sine 2s and divided by 2. This is the antiderivative of this function, and you integrate it from 0 to t. Again, this is v1. And it's going to be using the fundamental theorem of calculus. We can find that this is going to be, so if you plug t into s, you have t minus sine of t over 2. If you plug 0 into s, 0, 0 into sine, 0. So you just have -4 t plus 2 sine of 2t. This is the function v1. Okay, keep in mind, this is v1. Now go to find v2. v2, by the definition, is going to be equals to integral of t0 to t, y1 in terms of s times f of s divided by the Karnskian of y1, y2 in terms of s ds. All right. Here we have, again, y1 is, by definition, is not by definition, but by the, how did we define it, is sine. It's cosine, y1 was cosine. All right, just want to make sure. y1 is cosine. Cosine of 2s multiplied by the tangents of s, 8 divided by 2 ds. Okay. So again, I'm gonna cancel this. It's gonna be 4. Move the 4 to the front. T0 is 0. Cosine 2s and tangent of s. Go through all the trig identity. I have another identity to say cosine of 2s equals to cosine square of s minus 1. Two cosines of s minus 1. Actually, it's not just cosine. cosine of 2s is 2 cosine of s minus 1. That's what I could remember. All right. Now we just need to place cosine of 2s by this. So it's going to be 2 cosine square of s minus 1 multiplied by the tangent, which is sine of s over cosine of s ds. So here we will have distributed out, right? You would have still tangent of s, and you can simplify this to get, you still have 4 here, t0 is going to be 2 cosine of s times sine of s minus sine of s divided by cosine of s ds. Okay. So because I cross out the cosine and cosines, cosine here, that's okay. Now, remember we have this, we remember this, this is a trig identity, and it's just actually just sine of 2s, and we want to convert it back to sine of 2s because it's easier to find the integral. So it's going to be 4 t0 sine of 2s ds. I just split it in two different, and this is tangent, or I just keep it that way because you can use substitutions to find this integral. Okay, if you remember, this will be, I want to move it over here. Okay, so from here you will have 4 times sine of integral of sine of 2s will be 4. The antiderivative will be negative sine, negative cosine of 2s divided by 2. And you integrate it from 0 to t. And this one will be natural log. So if you let u equals to cosine, right? Then du equals to negative sine ds. So this is going to be negative du, negative, negative, positive 1 over u. So it's going to be natural log of positive, natural log of cosine of s. Go from t 0. Okay. So you found the antiderivative. Now you just need to use the fundamental theorem of calculus to find this v2. Again, we are finding v2. It's gonna be, I simplify this first, so it's just 2 cosine of 2t, negative cosine of 2t, minus 0, put in here, it's just negative 1. Minus, so put 0 into s is cosine of 0 is 1, negative of 1 is negative 1, so it should be plus 1. Okay. Plus natural log of cosine of t. Because if you plug 0 into s, you got cosine of 0 is 1, natural log of 1 is 0. So this is what we only have here. So this is actually v2. So we found v2 is this functions. And we found v1 is this functions. Then we can formulate the general solutions to this differential equations yt. C1, y1, which is cosine of 2t, plus C2, sine of 2t, plus y1, v1. y1 is cosine of 2t, times v1, which is, I remember, is negative 4t, plus 2 sine of 2t, plus v2, right? y2, which is sine of 2t, multiplied by v2 here, which is So little long 2 negative cosine of 2t plus 1 plus natural log of cosine of t. All right. So again, this is y1, y2, y1, v1, y2, and the whole thing here is v2. Okay. So remember, if you want to find the particular solutions, then you need to find what? You need to find y prime. So let's see. Y prime of t equals to negative 2c1 cosine, no, sine. Take the derivative, so it's going to be sine of 2t plus 2c2 cosine of 2t. Okay. And then we'll find this derivative. It's going to be cosine of, it's going to be negative 2 sine of 2t multiplied by the whole functions. Then you have to use the product rule plus the derivative of this function will be, well, I'll move it down here. Take the cosine of 2t, keep it the same, and multiply by negative 4 plus 4 cosine of 2t. And then go to this functions, you have, again, 2 cosine of 2t multiplied by just the functions plus 1 plus natural log of cosine of t. Okay, and also I have to plus the derivative, so keep this function's sine of 2t and multiply by the derivative of this function. So the derivative of the function, which should be 2, the derivative of natural log of cosine will be 2 negative sine, so negative will be positive, so it's going to be 2 sine of 2t. Derivative of 1 is 0. Okay, plus 2, the derivative of natural log of cosine t should be 1 over, you're going to use chain rule here. So u equals cosine negative sine of t divided by cosine of t. This funny, this is going to go back to the tangent, right? The tangent of t. Okay, just leave it like that for now. So what are the initial value? The initial values are 0, 1, 0, negative 1. Okay, keep it in mind. So if you have y0 equals 1, and you have y prime 0 equals to negative 1. So what does it mean? That means you plug 1 in here, and you plug 0 in here. And here, 0, so this is going to be 0. It's going to be 0. This is going to be 0. If this is 0, the whole thing is 0. This is going to be C1. 0 is going to be 1. It's going to be 1. Negative 4. Oh, this is going to be 0. So just C1 equals to 1. Oh, that's easy. How about y prime 0? So that means you have 1, negative 1 on this side. 0 is gone. It's gone. Whenever you have sine, it should be gone. Gone. So you have here cosine of 0 is going to be 1. So it's going to be 2c2. 0 is gone. This is going to be 1. This is going to be 1. So you will have 1 times negative 4 plus 4. Oh, this is going to be just 0. And this is going to be 1. 2 times 1 is 1. This is going to be 1. So, and this 0 here, so it's going to be 1. Natural log of 1 is going to be 0. So the whole thing is 0. So this is 0. And I just have 2 here. I have 1 here, but it's negative 1. Then plus 1 is 0. So it's just going to, the whole thing is 0. So what left over is just one term right here, right? Everything else should be 0. Oh, then I found C1 is 1, C2 is negative 1/2. Then my particular solution will be this function's here, but you plug C1 is 1 and C2 is negative 1/2. So the particular solutions multiplied by V1, and we know negative 40 plus 2 sine 2t. Okay, plus y2, which is sine 2t, multiplied by v2, which is 2 negative cosine 2t, plus 1, plus natural log of cosine of t. This should be your particular solutions. What a long problem. But this is an example of how you can use the variation of parameter method to find solution to some IVP in this form, right? In the form where you have this form up here, you have all the second differential equation in the form with all of the good conditions then, and if you can find the fundamental set of solutions to the homogeneous equation, then you can use this method to find your general solutions and particular solution for an IVP.